So in number 5, we have a dentist drill that starts from rest. After 3.2 seconds of constant angular acceleration, it turns at a rate of 25,100 revolutions per minute. A, find the drill's angular acceleration. Well, first things first, we need to convert this rather unusual unit of revolutions per minute into our standard form, which is radians per second. To do that, just a little bit of unit conversions. We've got this many revolutions per minute. We know that there are 2 pi radians in each revolution, so I'll get rid of that. And then for minutes, we know that 1 minute is equal to 60 seconds. If we multiply that through, we'll discover that the final angular velocity, that would be omega final, is equal to this number right here, 2,630 radians per second. Just real quick, because we know it starts from rest, that's our initial angular velocity, which in this case is just plain 0. So when solving one of these, we're looking for angular acceleration. If we were trying to find regular acceleration, we would just take the change of velocity over the change in time. While translating this equation, it's fairly simple. Angular acceleration alpha is the change in the angular velocity omega over time. Well, in this case, it gained this many radians per second, went from 0 up to this value that we just found in this many seconds. And if you divide it out, you'll discover that the angular velocity is this. Part B asks, what's the angle in radians through which the drill rotates? Well, this is kind of like displacement. And we could use this equation, or actually we could use just about any of them that have displacement at this point, because we know the time, we know the initial angular velocity, the final angular velocity, and we know alpha. I'm just going to use this one, and if we translate it, we get this. Delta theta equals the initial angular velocity times time, plus 1/2 times the angular acceleration times time squared. Plugging in what we know, the initial angular velocity is 0, the time is 3.2, alpha is the number we just found, 821, and again time 3.2 squared. Solving this, we'll discover that it rotates through 4,210 radians. And yes, we could convert that to revolutions by dividing by 2 pi, but all they're looking for in this case is the angle. I hope that this helps.